Hello everybody, thank you for being here. And I am Marco, and I founded my company, Coan, in 1996, sorry. And I'm a developer of the Open Embedded project, which is the foundation of the Yocto Project. And I am a Yocto Project advocate since 2012. So this is the reason why I continuously promoting this project for the embedded devices. During this audience, where obviously you are a far better programmer than me in the Qt field, I am trying to propose you a different kind of usage of the executables, of the programs you are developing daily. And doing that, we are going to see how to install and how to manage the Qt development and deploying, and of course also the debugging, using the Yocto project, which is nowadays the de facto standard for Linux embedded systems. You can find all the slides into this link if you need it, and you can do everything you want with the slides as well. Okay, the abstract is saying that I'm trying to... Sorry. Welcome. And okay, the abstract is saying that what I'm trying to explain you today, I try to start with this agenda showing you what is an embedded system. So I'm trying to start from the very beginning for who of you is not used to use embedded systems. And for that reason, I'd like to know who of you has already used an embedded system with Qt so far? Okay, not much people in this room. That's a good thing, because I have something to teach you. Sorry. And okay, so what is an embedded system? Which are the difference between a normal distro and an embedded distro? I am focusing only on Linux, skipping all the other operating systems, because I decided to drop the Windows embedded field in 2010, for example. Although I was an official trainer until that data. And okay, how to use the Qt and embedded system, how to use the Yocto project. So we are going to go deeper into the system itself, and in investigating how to use the specific components used to implement the Qt 5 inside the Yocto project. At the end, we start analyzing how to customize it, how to customize the environment, adding the several components you can use with the Qt the Qt layer, and deploying and debugging it into the real hardware. And at last, a small demo running the Qt image generated with the famous cinematic experience demo on a Raspberry Pi. So what is an embedded system? An embedded system is nothing more than a normal PC with limited resources. The limited resources are typically due to a small amount of memory and a limited amount of disk space. There are other several features that you have to take in consideration, but this is not the place where we can discuss about that. So we need to define and to understand which are the features of our hardware before we start to defining how to build the system for that kind of hardware we want to use. We can define two big areas in embedded system. The first one is the bare metal, so-called, because you are implementing all the software by hand from scratch, in any case without any kind of operating system. So you are alone on yourself to solve any kind of problem you can face during the development. I have to admit that I think I understood that with Qt Lite is possible to deploy and to manage such kind of devices using Qt. So with bare metal, you should also use the Qt environment. But I never tried it, of course. With operating system, there are several possibilities. Some of them are supported by the Qt system. So, for example, Android, Linux, Windows Embedded, and as far as I know, VxWorks and QNX, probably. Correct me if I'm wrong, sorry. And there are other operating systems not supported by Qt, but anyway, interesting from our point of view because can be adapted together with Linux. So, I mean FreeRTOS and Zephyr, which can run on Cortex-M devices, for example, to implement a kind of real-time control mechanism. Okay, said that, we can start looking inside the Linux distributions. Linux distribution is one of the most confused term in the Linux world because probably is not very clear what means distribution. Actually, it is the selection of the components and the version of the components we are using inside our system, so inside our distribution, in fact. So, what can we do with the Linux distribution? We can use a normal distribution or an embedded one. If we consider the normal distribution, we have several possibilities. Those listed here are not embedded. And we can have the Debian family, including Ubuntu and all the variants, and Red Hat, Fedora, and many other variants. There are a lot of other distributions, of course, available. Depending on the version of the distribution that you are using, you may have different packages doing the same thing. And depending on the version of the same distribution, you can have different packages, version for doing the same thing. This means that, for example, the standard editor for Red Hat may be different from the one used by Ubuntu or maybe, most probably, with Lubuntu or something with different characteristics. Which are the typical characteristics between the distributions are the set of components used to manage the graphics. And here we are entering into something that could be interesting for the Qt developer. Because we can have a different weight of the libraries used for the graphical component, and so different possibility to embed the system into a real embedded hardware. In any case, the typical not embedded distribution are quite big and heavy, so this means that if you want to use them into an embedded system, you need to cut them out, removing all the components that are not important for your system. So, from the system integrator point of view, which are the possibilities you can have? Typically, they are listed here. The first case is the Linux from scratch approach that gives you the possibility to decide which component you want to have, but you need to know every single detail about what you are building. You need to know everything about the packages you want to use, the version, the compatibility, and most importantly, the dependency hell, because it exists also in Linux, not only in Windows. And this kind of dependency is usually managed automatically when you are using a standard distribution, because standard distribution, which is the second row, is managed using a packaging system, which can be RPM for the Red Hat family or Deb for the Debian family. In the case of Yocto Open Embedded, we typically are using the IPK format, which is lighter, offering you more or less the same features. So which are the pros and cons about the choices you have are listed here. So when you have the binary distribution, you have the easy way to start, but you have a very hard time to cut off everything you don't need to reduce the size and the memory consumption of your system. So the third choice, which has been developed by developers who was asking to have something to automate the distribution creation process, have been done using systems like Yocto Open Embedded, which is the foundation of Yocto itself, Buildroot, PTX-dist, OpenWRT, and several other build systems. I could say that nowadays the Yocto project is the de facto standard because all the major silicon vendors are using it and offering a set of software, a system called in technical way layer, offering a layer to support their own kind of platforms. So which are the benefits of the build system approach is that you have the complete possibility to customize every single detail of the system, and you don't have any hassle about the hassles to know every detail about the not compliances and the problems of the various packages involved into the distribution creation. Of course, that is not so easy. As using a binary distribution. But this gives you a very wide possibility to tune your system. And the approach adopted by all the automatic build systems are more or less the same. So you have components, software components coming from the internet or from other resources outside the build system. The build machine where you are running the automatic build system, and in-house or in the machine components that you need to build your own projects. So using this scheme, you can have you can build the operating system and all your components you are developing in the company. We will see later how to deal with that with small or large groups of developers. The embedded Linux build system is responsible through a configuration made by the user. The user in this case is the system integrator to define which components I want to have into the distribution itself and how to tune them in case this is possible and allowed by the package that I'm trying to manage. And this is the case of Qt, for example, because Qt is a component I'm taking from the internet. I need to build it, but I need to configure it to get all the small details that I need to deploy and to let run my application on the target. The final result of this workflow is usually composed by these 4 components. 3 of them are the main components which are part of the so-called BSP, the board support package. And that is composed by the toolchain, which is the first brick you need to build everything. And after that, after the toolchain creation, you can start to take into account the bootloader creation and the kernel image creation. Of course, when I mean kernel, I mean kernel and device tree. The root file system image is created using in the same flow, but is not part of the BSP, but is part of the file system itself. So that can be considered a separate component. In fact, on many architecture, you can swap very easily the BSP components and the file system without any problem. For example, if you are creating a system for a Beagle Bone Black, you can run the same file system, replacing the kernel for an MI6 machine, for example. That always, of course, that depends on the features of the CPU, on the optimization you have used for the toolchain creation. It's not always a valid feature, and is not a best practice. It's only used by, I use it only to do small tests or quick and dirty tests to see if something is working before starting to work on the customer device. Okay, now let's start to have a little tour into the Qt, but seen from the embedded point of view. And looking inside the Qt website, we can see that there are some interesting definitions we have into this link. Okay, we can take in account even the other topics above in the next slides, but I would like to focus on the embedded tooling solution because we are discussing about embedded systems and reporting that into the next slides. So I wanted you to have some reference to compare with I have into my slides. Here you can see that there are the two typical licenses that probably everybody knows, the commercial and the open source one. And of course, I am focusing only on the open source one. Okay, another important thing about the open source license is that starting from, I think, 5.7, the license switched from LGPL2 to LGPL3. And what does it mean to have the LGPL3? You will discover it better tomorrow in the Burkhard Stubert presentation that I want to attend.
Thanks for the ad.
Because it looks very interesting, but if you miss it for any reason, sorry, I have another note. On April 4th, which is Wednesday, there is the webinar on the Qt website discussing about the licensing system. So you can ask every question you have, everything I haven't explained well now, or maybe wrongly. Okay, so you have the opportunity to, at last, discover all the details about the licensing of this library and the licensing of the LGPL3. However, this library has been created to avoid that people create systems using open source and closing everything with a locker, basically. So this means that every time you are deploying, every time you are selling a device containing the Qt library, you need to allow to your customer to reprogram the library itself inside the device, in any case. So you can't lock it using the so-called TIVO mechanism or TIVOization mechanism. So, okay, I don't go further with that. It is only to mention why we are discussing all the remaining parts starting from here. Because there are several limitations when we are considering to use the Qt library into the embedded systems. Because one thing is developing with Qt using desktop systems. Maybe they are living and running only into your company, so you are completely free to do whatever you want. But when you are selling a device using this library, you need to comply with the library itself. So you need to have the commercial license or respect the LGPL3. But there are some components that are not released with the LGPL3. And we are going to see to them now. For example, additional features and tools available from the host point of view, I mean on the developing machine. We don't care about that because we are focusing on the target system. So you are free to do whatever you want. If you want the support, you call Qt and you buy their support, their beautiful packages, etc. But from the from the open source point of view, which features and possibilities we have? Okay, we need to manage all the components available under this kind of license. And their setup and management can be difficult because they may be not straightforward and not working out of the box. There are some companies, silicon vendors, or third parties, board producers. Many of them, I think all the ones present and sponsoring this event are providing excellent support and systems running out of the box. But there are some that are not working. So you need to tune your system. So what is the difficult part of the system integrator of an embedded system? This is an excerpt of what I've seen, what I've shown you on the previous website. So there are the direct on-device debugging, one-click deployment, and Qt sources for do-it-yourself embedded software stack that looks something absolutely crazy, but is very easy. This means I want to develop with Qt on my embedded device. The other components listed here in red are not covered here because have different license and are not into the GNU ecosystem. Okay, so they are not, I could say, not open source, but because you need special licenses. I mean, for example, the boot to Qt, which is a beautiful component that allow you to fast boot your system, and not only from the boot time point of view, but I mean from the startup of the project and development of the project, because you have everything ready to run, but someone needs to prepare the system for you. And this is one of the tasks done by the Qt company, as far as I know. Maybe I'm wrong. The Qt configuration tool called Qt Lite is the system that allows you to go on not on system without operating system. And the virtual keyboard I listed here because it's a frequently asked question. And it has a GPL only license, and we will see which impact this have on your build system from the system integrator point of view. Let's start with the remote debugging. It's very easy. Everything is very easy. Everything I listed so far is very easy. You need to use the GDB debugger provided by the GNU project. Period. But you need to be careful about how to use it, because when you are cross-debugging is like cross-compiling. What does it mean? Means that I am building and debugging on my PC comfortably sit on my chair, but I want to debug on my hardware, which is a completely different system. Maybe even not the same architecture. Maybe I'm developing on a PC x86 and deploying on an ARM processor. So it is important to define properly the cross-debugger. And we will see later all the details about how to set up all the components listed now. The target deployment, probably the people used to use the Qt creator already know this feature. You need to edit the .pro file and enter these two lines saying, I want to deploy on a target system and I want to deploy my executable in this directory. You need, of course, to configure properly the kit and etc., etc. We will see something later about that. But there is an important step now, and it typically is the most difficult part for the Qt developer beginning with embedded systems, because usually when you are creating an embedded system, you are using the default SSH daemon on the target. And what is it? It is dropbear. Why everybody is using dropbear? Because it is the lighter, and embedded means lighter, or as light as possible, usually. But unfortunately, if you are using the dropbear, you won't be able to deploy your application simply clicking on the beautiful green arrow on into the Qt creator. So you need to switch from dropbear to OpenSSH. This is the first trick I am teaching you today for using or creating an embedded system. Sorry, just a moment. Of course, if you have any question, you can interrupt me at any time. Let's go ahead. Now, we need the standard software stack, so the very complex definition for a very simple thing, which is a MetaQt 5 layer to use and to add into your Yocto environment. You need to use this component, and where is this component? You have listed here in GitHub. You can download it, and I will show you how to use it. Oops. Okay. And, okay, boot to Qt software is not covered here, but is covered only to show you that boot to Qt is using MetaQt 5 as well, but in addition has a meta boot to Qt component. So if you want to use it, you need to discover how to use it, how kind of license you need to use, and possibly contact the Qt company. You have, even in this case, all the links to discover more about this component. The virtual keyboard is requested very often because when you are creating an embedded system, probably you need to enter a password, something, your name, whatever you want. But if you want to use this component is released in GPL only. This means that you need to release the sources of your application or buy the commercial license. If you want to use it, you simply need, of course, to enter this line into the main function, and every input field you have into your application automatically will show you this kind of keyboard, which is beautiful because it supports every kind of language, internationalization, etc. However, as many of you probably already know, when you want to create an application proprietary using the Qt library, you need to adopt this scheme. You need to have the dynamic linking of the library, keeping in mind that you are using the LGPL3. So you have to allow to your customer to reprogram or modify the library itself. Okay, how to use the Yocto project now? And what is the Yocto project? It is a collection of components. It is a collection of components providing a minimum set of software components that gives you the possibility to create an embedded system. The supported embedded systems are provided into MetaPoki and MetaYocto BSP, and they are some QEMU emulators, and into the Yocto BSP there are 4 or 6, I don't remember exactly, reference platforms. One of them is the BeagleBone Black. If you want to extend the standard behavior of the project, you need to add your or some third parties layers listed here. The supported platforms are x86 and all the major the embedded device you can buy nowadays. The system is based on Open Embedded, because Open Embedded is contained into the meta layer called Open Embedded Core, where there is the engine, the build engine of the system. Okay, the Yocto project is composed by packages, and these packages are used to build all the bootable images. It supports the packaging system, so we have packages, but we have also the packaging system. It is released very frequently, it is very stable, and it includes all the components that we need to create and deploy our operating system. So toolchain, the packages, etc. There are also some components available to add Clips plugins, or it is possible to create an SDK or even a graphical interface, a graphical web interface to configure and start the build of the system. It is called Toaster. The versions available are listed here, and the latest stable one is THUD, released on October 2018. What we have inside the Yocto project, and particularly in this case inside the Open Embedded Core system, we have the BitBake, which is the engine, the real engine of all the system. We can consider BitBake as the make into the for compiling C or other source code. So this BitBake is responsible to parse and compile the artifacts listed into the recipes, which is another important component of the Yocto system. The metadata are the components listing how the several components you want to have into the final system are composed, where you are getting the sources, how do you need to build them, how to need to deploy them into the final system, and most importantly, which are the dependencies of the package itself. So the system is able to manage and solve automatically the dependency of the several components included into your system. Again. Okay, Poki is another component, usually quite misunderstood, because Poki is the reference distribution of the Yocto project. So when you are building with Yocto, you are generating Yocto Poki distribution. You are not generating the Yocto Linux distribution, but it's not a problem. You can call it whatever you want. I'm not so radical as my colleagues. So, for example, how can we start using it? Very easily. You need to git clone the basic component, which is done using this command, and you get all the layers needed to start with the system. And this is only the starting point. Starting from there, you can go inside these two web links where you have the list of the several layers available for the Yocto project / open embedded system. As you can see, we have, probably you don't see actually, but Meta AMD, Meta Freescale, Meta Intel, Meta Qualcomm, and Raspberry PI from the board's point of view. There are other layers. Most of the layers are listed into the layersopenembedded.org because here are listed only the layers complying and probably paying a fee for the Yocto project. So what I need to do if I want to play with the Raspberry Pi, I simply need to add my Meta Raspberry layer to what I have downloaded so far. So in addition to the 3 basic layers, I need Meta Raspberry Pi. And if I want to build with Freescale, NXP evaluation boards, I need Meta Freescale. If I want to use other components, like for example, Toradex, which is a third party, you have Meta Freescale third party. And you find inside this layer all the components pre-configured, offering you the possibility to build the BSP out of the box. Here I have a case study just to show you how to customize the layering system. Let's take, just for in case, the Toradex board. Okay. Toradex is typically using the open embedded environment to build their system. I want to switch everything to Yocto Poki, which is not supported by default, so I created my system. You can download everything using the repo project, which is a package responsible to manage automatically a list of Git repositories. It is created by Google. You download this from this website and start with the repo sync, and you get, okay, the content is listed here, so you can study it or use it as a starting point to customize your environment, and you get something like that. You get all the components in green, and I added, we at Coan have added to the standard Yocto system the Meta Qt5. Of course, we have also the Freescale and the Freescale third party because I want to support the Toradex boards. Okay, let's go ahead and let's see what there is into the Meta Qt5. Meta Qt5, how I downloaded it using git clone metaqt5.git or using the instruction in the previous slides. Depends if you want to use the mechanism I prepared into my GitHub website, like this, which gives you everything in one shot, or if you want to download every single component by hand, maybe is more interesting from a learning point of view because you are downloading every single component and you are more aware about what you are doing. Okay, you download the Meta Qt5 and you could use it more or less out of the box because this gives you the possibility to build the Qt workspace inside the Yocto project. But, okay, as far as you downloaded the Meta Qt5, you need to update the bblayers.conf, which is a typical configuration file of the Yocto project. You need to add this layer to the system. In this way, BitBake will know that you have added the Meta Qt5, and you can start customizing it. And the customization is a matter of defining, for example, the abstraction layer already discussed this morning by okay, ecco, Tiago, sorry. Exactly. And you can find more details here about the several options of the abstraction layer. And what do you need to set up? The first thing you need is to understand if your hardware is supporting one of these components. Typically, we have AGLFS with the MX6 or Raspberry Pi. And in order to enable this feature, you need to define into the local conf, which is another important configuration file of the Yocto project, to say, I want not to use X11 and Wayland, because this windowing system doesn't allow the use of this acceleration, graphical acceleration. Once you have built your system, you need to launch on the target your applications specifying the kind of platform that you want to use or exporting it into the environment of the target system. If you have another board, just to have a different case, for example, Atmel microchip is not using the EGLFS, but is using Linux frame buffer directly. So you need to remove the standard components used by the windowing system, but even the OpenGL. And you can start the system, your application using platform Linux FB. How can you add a custom layer? Add a custom layer to customize Qt5, which is the last step in your Yocto adoption for building your distribution. Once you have all the system working, typically you can start with Yocto, the MetaFreescale, and whatever you want for your hardware. You can add the Qt5. You can start building, I don't know, the cinematic experience, and you can see if everything is working. When you want to add your components or customize it, you need to create a custom layer, and this is the one in red here. So you create a custom layer using the commands available provided by the Yocto project. Bit-based layers create layer. You need to specify the path of your layer, and the name is metacoan here, and you need to add it to the configuration file. You can edit the file manually, or you can use this command, it's the same. Afterwards, you can customize the Qt behavior directly into your layer without touching anything existing in the original layer. This is the standard behavior and the best practice when you are developing with Yocto project. So basically, inside your layer, I mean the metacoan in our case, you add a QtBase underscore bb append file, and this means that I can replace with this wildchar to every version of Qt available into my system. So in this case, I don't care about it. And I say, I want to add to the configuration of the system to support the graphical acceleration system. Very likely, it is already included into your system, particularly if you are using the Toradex, just to say a name. Okay, let's go ahead. I want to customize this deeper. So typically, you may need to add the SQLite support. What do you need to do? In exactly the same file, you add package config underscore append SQLite. Automatically, you will get into the target system all the components needed to have the possibility to use the Qt library with SQLite. And there are many other cases. For example, in here we have a more complex case when you can define conditional configuration of the system. How does it work? You can define like the configuration of a certain package, saying that I can configure it if this variable is activated into the system. I configure it with this function or without this function, and I can build this kind of dependencies or another set of dependencies. So completely, I have two options depending on the presence or the absence of the value you have into the brackets. Another thing, if you want to use the serial port to communicate, the library to communicate on the serial port, you need to install into the system, using this keyword, image install append Qt serial port. This automatically will include into the final system the library needed to communicate with the serial port. And the famous virtual keyboard. If you want the virtual keyboard, simply add it using image install append, and it will be enabled into the system. Of course, you need to rebuild every time you change one of these settings. 5 minutes. Typical issues. Typical issues, I'm developing a beautiful, cute, quick application. It works on the PC. I deploy it, and, oh damn, it's not working. I get this error. Okay, because I forgot to install the Qt quick controls, for example. What I need to do into the configuration file, I add image install append quick controls 2 or 1, depending on what you want to do. And last but not least, you can create your beautiful image in one single shot. You create a Koan Qt5 image, including all the components you like in one single configuration. Every time you build this image, you will get the Yocto project plus the components you have listed here. Application development. Now, so far we have seen how to create the system. Now, let's focus on how to deal with the daily work of the application developers. The application developers may not be the same of the one developing with Yocto, because Yocto is a matter of system integration, can be complex. And we want to care about the application only. So I am the system integrator. I am responsible to provide you a meta toolchain or a meta toolchain Qt5. Using this command, I can generate the redistributable toolchain for all the developers into my company. And they can work in this way. I am the Yocto project manager releasing the image on the target system. And all the other developers that want to focus only on the application, so the very good developers, the very good Qt developers, can work into their comfortable environment, because I provide them the SDK to deploy the application on the target, exactly as they did on the PC. What I need to do that? I need to go into this directory, into the build system of Yocto. I find this auto-extracting script. I distribute it to the developers. They can install it, and they need to call it in this way every time they want to cross-compile. This is the script needed to set up the cross-compilation environment. How can I cross-compile? Here we have an interesting trick. If you want to cross-compile, you need to remember to set up the cross-compiler before starting the Qt Creator. So the easiest way is to edit the Qt Creator SH launcher and add the cross-compiler environment configuration in the first line of the script. And starting from now, you can call the Qt Creator using this command instead of the other one. So you can have two icons on your desktop. You can start the Qt Creator for x86 or for cross-compiling. Of course, when you are cross-compiling, because you are using kits, you can compile for several environments, not only the one set by this variable. But this is needed if you want to cross-compile for your target board. Last steps are to set up a kit. So you need to set up CMake, QBS compiler and version, taking them from the directory where you have installed the cross-compiler. Probably you can read it when you get the slides on your PC. To deploy your application, you need to set up inside the kits. Here, in the kits, there is the possibility to define the IP address of the target system, the password, which with Yocto is root by default, okay? And you can, starting from here, you can deploy because you have set up the OpenSSH daemon instead of drop beer. If this is not working, it's because you forgot to change it. In fact, I repeated it here for your convenience. And you can define which kind of target to use and deploy your system. If you want to debug, you need to remember to put into the configuration to append the bug tweaks, but it is set by default, so you are lucky. And in this way, you can cross debug on your target. So you can put breakpoints on your desktop and see the application working on the target with the breakpoint. Demo on real hardware, just because I finished. Meanwhile, I am connecting the board. If you have any question, please ask me. I leave the mic. Thanks.
Any question?
Vediamo se funziona. I changed the splash screen here instead of the standard Yocto. So my friends from Open Embedded will be happy. And here we have the typical cinematic experience running on the Raspberry PI. Yes? Question?
How can we set up the boot time for the Raspberry or the image of the Linux? There's some in Yocto Project. There's some way to fine-tune the.
No. Do you mean to reduce the boot time?
Yeah, to reduce at minimum.
Sorry. Yes, to reduce the boot time is hard work because for small amount of time you need to do a large amount of work. So the tricks are always the same. Reduce the size of your bootloader. Reduce the size of your kernel. Remove the timeout when the bootloader is starting. Let's start your system as soon as possible, loading the device drivers earlier. So the user has the impression that the system has booted, but is still in boot process. Yes, typically this is one of the tricks you need to follow. And select the proper components, the lightest one, but not in every case that is possible. So depends case to case, device to device. And it is not easy. Thank you, friend. Other questions, please? Okay, if you have any question in the next days, you have my email on the slides. Write me, and I see if I have time to answer to you. Will be my pleasure. Thank you for coming.